Guys, I'm back with another example on finding the equation of a tangent line, but this time the given function is like a ratio of two functions. So you can think of this also as a rational function. And obviously when you see a rational function of this form, we want to find the derivative of this, we've got to use the quotient rule, right? Quotient rule works when we have a function divided by another function. But in order to write the equation of a tangent line, we first have to recall the equation. The equation looks like there's two ways. I prefer the slope intercept form, y minus y1 equals to m and subscript tangent, because we are interested in the tangent line, and then this x minus x1. So guys, I already have my x1 value because I'm interested at x equal to 0. So the first step is going to be, for me, the first step is going to be to identify my x1, which is 0, and also to find out my y1. It's not directly provided to me, but if I substitute x equal to 0 in the original function, what I get is going to be my corresponding y value for that point, which is going to be y1. So to find that y1, I go back to this function and I substitute x equal to 0, right? And then I try to substitute that on the right hand side. It's going to be 0 plus 1 divided by 0 plus 2, which is just 1/2. So my x1 and y1 point is 0 and 1/2, 0 and 1/2. So I will just leave it as a fraction. 1/2, you can also change it to 0.5, like a decimal, but most of the times we like to work with just regular integers and fractions, so I'm going to leave it as 1/2. Guys, the other thing we need is to find the slope of the tangent line. We know the slope of the tangent line can be calculated by just evaluating the derivative of this function at that particular point. Now, looking at this function, what is the way, like how are we going to evaluate the derivative? We're going to use the quotient rule. Guys, we already know how to use the quotient rule. We got to treat this as f and this as g, and then apply the quotient rule. I'm not going to just rewrite the rule. Now we already know the rule, so we're just going to apply the rule. So to find the derivative of this whole function, we got to do the derivative of this first, the numerator, which is just 1, and just I have to multiply by the g function, or by the denominator, whatever is in the denominator, that's this. And but guys, there's a minus, don't forget that there's a minus here. Then I have to take the derivative of the denominator, the derivative of the g function, or the denominator, is also 1 here, and then multiply by the numerator, and numerator is just x plus 1. And then we got to divide this whole thing by the square of the denominator. So guys, this is my derivative, but I'm interested to find the derivative at x equal to 0. That is going to give me the slope of that line. So let us go ahead and see how we can do that. So I just have to substitute x equal to 0. Now you can simplify this first and then substitute. That is fine, but you don't really have to simplify first, because working with 0 is not going to be too complicated even if you just substitute it right away without simplifying. Okay, so 0 plus 2 is just going to be 2. 2 times 1 is just 2, minus 0 plus 1 is 1, 1 times 1 is 1, so it will end up, the whole numerator will become just 2 minus 1, and downstairs 2 plus 0 is just 2, 2 squared is 4, so finally I will have 1 over 4. That is the slope of the tangent line. Guys, I have everything that I need to write the equation, so let us go ahead and finally write our equation. So for the slope, I got to write 1/4, that's what I have for the slope. And then x1 and y1, we already have the values for x1 and y1, which I'm going to just substitute here. Guys, what is my x1? 0, okay. And then y1 is 1/2. So in fact, if you want to simplify this, you can actually ignore that 0. So we don't have to even write that 0. So it's just going to be 1/4 x. You can write it like this, or if you want to convert it into the y equals to mx plus b form, so that would simply be, you just add 1/2 to both sides, so it would look like y equals to 1/2 plus, or if I want to write it the x term first, 1/4 x plus 1/2. So both forms are perfectly fine. It's up to you which form you want to leave, or depending on what the problem says. Okay, so guys, it's not too complicated how to write an equation of a line given a nice function and given a point that we are interested in, to find the equation of that line. So you got to use the combination of, in this case we had to start with the quotient rule, and then of course in all of these problems we still have to keep on using the power rule. Okay, so guys, these were some examples on the product and the quotient rule. In my next videos I'm going to be talking about a different technique, a new technique of evaluating derivatives, which is also called as the chain rule. Okay, and then we'll take a lot of different examples on the chain rule, and then we'll move on from there. Okay, till then guys, please take care and keep practicing these problems. If you have any questions, just get back to me through my YouTube channel, through comments or anything, and I'd be happy to get back to you, and I can do some of those problems here. I can provide you some hints. Okay, take care, see you next time.